All right, here we are looking at the addition and subtraction of radicals. My name is Matthew, and this is not going to be a very long video because if you joined me for the previous video, you already have some really good insight and then hopefully went on and did some practice with regard to simplifying radicals. And at least what we're seeing on the first part of these notes, this is going to look and feel a lot like combining like terms. And in fact, that's exactly what it is. Let's go over to part B that says 5 cube roots of 3 minus 6 cube roots of 3. So the 5 and the 6 are telling us how many, and the cube root of 3 is what it is that we're actually subtracting. So I've got 5 of them, take away 6 of them, I end up with -1 of them. -1 what? -1 cube root of 3. Is it really that simple? It's really that simple. Isn't that nice for a change? Let's look at part D. That's another subtraction problem. I don't really care what the square root of 3 is. Apples, donuts, Ferraris, digital pens, whatever it is, whatever you have laying around. I've got 4 of them. I'm taking away 2 of them, so now I only have 2. And then I take away 8 more. And what's 2 minus 8? Well, it's -6. So we have -6 square roots of 3. That's it. I'm just doing arithmetic with the coefficients while I'm losing my voice. F is very similar. 9 minus 4 is 5, plus 30 is 35, so we have 35 fourth roots of 7, and then that -2 is just kind of hanging around. It's not a like term. It's not a fourth root of 7. So we just sort of, we let it come along with us, but it doesn't really get to interact with us all that much. Excuse me. And then in number 2, part A, we get to use the sort of skills that we were practicing in the previous lecture, where we have to simplify these radicals first, and then hopefully we'll be able to do some addition or subtraction. So part A says the 5th root of the cube root of 8x. The cube root of 8x can be broken up into the cube root of 8 times the cube root of x. And then here's, oops. And then here's our plus sign. And there's another multiple of 5. And then there's the cube root of 125 times the cube root of x. So I'm just taking and breaking up these factors that are on the inside. Excuse me. And then still applying the radical. This is equal to 5 times 2 times the cube root of x plus 5 times 5 times the cube root of x. And since I've run out of room, let's do a little bit of arithmetic in our head. 5 times 2 is 10. 5 times 5 is 25. 10 plus 25 is 35. 35 what's? 35 cube roots of x. And there's your final answer. So it's that kind of a strategy. So that's a really good example because the numbers are pretty manageable. The cube root of 8, the cube root of 125. That's the kind of simplification that you need to be doing. Excuse me, still yawning. I was yawning in the previous video, I'm yawning in this one. It's now 11:35 p.m. So the simplification of these radicals is what's necessary in order to get what you might want to call like terms. Notice that this was cube roots of x, this was cube roots of x, and that's what allowed us to do the arithmetic, adding the coefficients 10 and 25 together. Part C is very similar to what we just did in Part A. You just need to tear those apart into some convenient pieces so that you can simplify some square roots. There's a 25 in here. There's a 100 that's in here. Okay, so and those are both square rootable. So make sure that you sort of factor out or carve out a 25 out of there and a factor of 100 out of the 600. Part E, however, is a little bit more unique. This is equal to the square root of 49 times x plus 1. So I did some factoring under the square root symbol, which we have not done yet, at least in the videos that I've been making. Plus, underneath the next square root symbol, there's a greatest common factor of x squared, with leftovers of x plus 1. All right, so now, since there's a product happening under both of those square roots, you've got 49 times x plus 1. You've got x squared times x plus 1. So the times that I was mentioning there is the multiplication, which tells me that I've got products. So we could, let's go ahead and break this up into the square root of 49 times the square root of x plus 1 plus the square root of x squared plus the square root of x plus 1. And then the simplification looks really easy, and it is. Square root of 49 is 7 times the square root of x plus 1 plus square root of x squared is x times, ooh, I wrote a plus sign there. That was supposed to be multiplication. So the square root of x squared was just x, and then we're stuck with the square root of x plus 1. And then really, inside of this expression, we've got these two terms, and inside of each one of those two terms is a multiple of x plus 1. That constitutes a common factor. So I wouldn't hesitate to write my final answer as my common factor, square root of x plus 1, times my leftovers, 7 plus x. Factor that thing all the way. Nice job. Do we need to look at any of these other ones? D, we don't. F. Not really. I mean, it's the fourth root of y to the third over the fourth root of 81 minus 5 fourth roots of y to the third over 3. This thing simplifies quite quickly. We've got the fourth root of y to the third over 3 because the fourth root of 81 is equal to 3 minus 5 fourth roots of y to the third over 3. And because we were able to take the square root, or rather the fourth root of 81, and turn it into a 3, we now have a common denominator. So here I have 1 fourth root of y to the third, and I'm taking away 5 fourth roots of y to the third. And what is 1 minus 5? Well, it's negative 4. Negative 4 what's? Negative 4 fourth roots of y to the third over the common denominator of 3. The figure has a perimeter of 24 root 5 centimeters. Find the value of x. The square root of 20 is equal to the square root of 4 times the square root of 5, which is equal to 2 times the square root of 5. So the top edge of that thing measures 2 square roots of 5, which, since it's a rectangle, the bottom also has a measure of 2 square roots of 5, for a total of 4 square roots of 5. Well, the entire perimeter is 24 square roots of 5. So perimeter equals 24 square roots of 5, which is equal to the 2 root 5 that we had on the top plus the 2 root 5 that we had on the bottom plus an x on the right-hand edge plus an x on the left-hand edge. So let's subtract 4 square roots of 5 from both sides of this equation. 24 root 5 minus 4 root 5 is equal to 20 square roots of 5 equals, combined like terms, x plus x makes 2x, not x squared, that's x times x. This is x plus x, so it's just 2x. And then we can divide both sides of that equation by 2. I had 20 square roots of 5, like having $20. Divide that by 2, you have $10. If you had 20, I don't know what, 20 soda bottle caps, and you had to share them between 2 people. 20 bottle caps divided by 2, 10 bottle caps. So the root 5 is the bottle caps. It's the units. There's your x value. There are undoubtedly myriad other little sort of silly example problems that we could create that are word problems, but not extremely common to see very in-depth word problems that somehow also manage to mix in the simplification and combination of radicals. However, these kind of perimeter or area problems are ones that you might see. Maybe in a college algebra class you would see some example problems that are a little bit more involved, where you're using the Pythagorean theorem, perhaps. But otherwise, I would say that the real key to working through problems from this particular chapter, and I'll call it a chapter because I've got these videos organized like a chapter in this particular YouTube channel, you really need to be paying attention to the rules and the properties that you're allowed to bring to bear on these problems. And since we're at the end of our last video in this chapter, come here. You want to come say goodbye? Meow. You want to come say goodbye? Sophie and I have had a lot of fun working through some problems with you this semester. Thanks so much for hanging with me. Good luck wrapping things up, and I will see you perhaps in another class in another semester. Are you waving? You've got a paw out. I like that. I like your style. Thanks, y'all. Take care.